All right. Oh yeah. Sorry.
Awesome. All right, did you guys get the sign-up sheet passed around? Maybe? Not yet? Okay, cool, it's fine.
It's just at the library getting the that study guide textbook and
There you go.
on a USB stick. I crammed a giant textbook into a USB stick.
Quick question for you guys. When is your final exactly again?
Tuesday. Oh, it's on Wednesday?
Wednesday, Tuesday. Wait, how many of you guys are actually in Zion's class?
I'm in Zion's.
So you're not in Zion's class. Okay, sounds good.
I'm the only one.
That's fine, that's fine.
There's no review sessions for either.
Really?
Yeah.
Do they not have an SI?
What?
Do they not have an SI? Yeah.
I think it's his first year teaching.
Oh, okay, that's definitely probably why. All right, is there anything that you guys specifically want to go over? Because it's on everything. So you guys kind of have to, I can't like do a review session for like everything. It's going to take forever. So I want to cater it towards what you guys want. So.
Do you know what the homo and momo stuff is going to be on it? Like, is that
The what?
The stuff we learned.
the lowest unoccupied molecular
Is it cellular
orbital?
10.6?
10.6.
Maybe 10.1.
And then the highest occupied
The homonuclear diatomic molecules. That?
I don't know. I don't know what that is. I don't know. We did it in labs and I don't
I am going to say you're probably not going to, because this final is not, it's not like a fourth exam for you guys. It's actually, like, okay, so it's basically a standardized test, like the ACT, like the SAT. But
Most of it being
specifically,
multiple choice.
yes, it's basically all multiple choice.
Oh my god.
Everything is multiple choice. There is no writing, having to do calculations, showing work. But the only downside to that is you guys don't get partial credit. So it's all strictly multiple choice. You guys have to be able to know your facts. Majority of it, I would actually say majority of it would be more conceptual than actually punching in numbers. That was kind of my downfall for that because I was more math orientated rather than conceptual. So it was a little bit difficult for me. But if you guys can understand the math and then using that to try to like backtrack and figure out what the concepts are, that'll help out a lot. I don't exactly remember these. Somebody's already messaging. I don't really remember the specific topics because it's basically just a general thing. It's very, very general. Like the class itself goes really in depth with each topic. Like during class, the exams are a little like in medium and like up to easier level. Basically, this whole entire general thing, because you guys are going to a tech school and it's like pretty intense over here. The thing is really, really shallow. It doesn't go that deep into what you guys have been learning. So that should hopefully ease some stress for you guys.
So it's more like the basic concepts of each little thing rather than the more intricate parts of it. Like
no, exactly. So they're not going to be like, they're just not going to get really, really specific. They're just not, because they have to accommodate for everybody that's taking general chemistry all over the U.S. So put that into respect. So to answer your question, I don't really think you really need to know that. I honestly didn't see any of that on the exam. So yeah. So is there anything else left? Is there anything else for you guys?
I guess.
Sorry.
You go on. Go for it.
Our blood classes have the same exam, or is
Yes, every single chemistry class, or 124 or whatever principles of chemistry 1 all across the nation actually take this exact exam. So everybody takes the exact one. Yeah.
Okay. I guess generally, say the hardest thing I had to deal with was gas law, so maybe a little bit.
Gas laws, okay.
Help.
Okay. Good. So gas laws. Do you remember exactly which chapter that was from?
It's like 5.
Yeah, probably 5.
That was 5. Let me check it out.
It is 5. The 6 was California.
Like
5 gases, yeah. Gases.
and chapter 6 too, thermodynamics,
And thermal.
thermochemistry.
True, yeah. Okay.
Do we have
Oh wait, do we have like long, you know, it's multiple choice, do we have like long calculated word problems on there or not? Really?
Probably not. It shouldn't. It's basically. I think it's around. Don't quote me on this, but it's like I think it's between 70 and 100 multiple choice. It might be less. Was it 60? Was it 60?
I heard 40.
Oh geez. Okay. Well, it's probably going to vary now because I have no idea. But you guys have 2 hours to do it. So I believe it was each question took about like 2 minutes. Yeah. So then there'd be like around like 60 questions or maybe even less. But you guys should be. You should be okay. You kind of just have to pace yourself. This is basically just standard testing, and it's like if you don't know one of the answers, just move on to the next one. And if you don't finish everything when the time is already cut off, fill in whatever random answers. Like just do it. Like
You have
it's better.
25% chance to get it right.
Exactly.
Might as well
Exactly.
take a
So
leap.
you might as well just go for it. Any other test questions specifically? Because I can answer all of those like pretty easily.
do we get equation?
You do get an equation sheet, but it's going to be really annoying because you can't separate it from the booklet. The booklet itself is going to be like front cover, periodic table, equations, first question. So, you know, yeah, so you're going to have to be flipping back and forth.
Yay! I love flipping between pages.
But it shouldn't be too bad. It shouldn't be too bad because some of the concepts that they want you to do for the questions should be pretty easy. Just like you're like, bam, I know what this is. You know?
Will there be any is there any restriction on calculators? Like you can't use Nspires or something?
I guess the highest you would be able to go is basically with, I think there's like this whole there's like a, whoa, what else I had? CHEM124 Plus is basically what I was using as a graphing calculator, so it kind of went pretty high tech versus for calculators. I think there's a TI-89, the one that's it has a keyboard and stuff. That one's you probably can't use that one on the exam. They're probably gonna confiscate it and give you they're probably gonna give you one of the ones that you guys do during the test. I hate those. Those are not fun.
Me too.
They're just disgusting. They don't do anything. Oh
Yep.
my god. Oh my gosh, I hate them so much.
I know what you mean.
No, yeah. Any other questions? Though? Any other questions? Any other questions? No, maybe yes. No. You guys can ask me throughout. If you guys want to. It comes up.
Should I just leave this time sheet?
Oh,
Yes, just do your signups.
all right. What specifically about gas laws do you not understand?
I just want to do some practice problems, just
Okay.
it's not something I don't get. I just need practice with it.
No, I got you. Okay, cool. All right, we're gonna just start with the basics, something that's really, really simple. Okay. So we're gonna do. Sorry. So this question is 4.00 liters of gas is under pressure of 6.00 atmospheres. What is the volume of the gas at 2.00 atmospheres? To make this a little bit more complicated, it should be pretty easy. I want you guys to list what law you guys were using, and if you guys can mention who discovered that law, that should be better.
Would it be 24 divided by 2? Yeah.
The shooting sign should pass around. You guys do not know. Cool. If not signed up, Alright, I'm just going to move straight along. This one should be pretty quick. Like, if you had this on the exam, it should be like, bam, you'll figure it out. My thought process, basically just figure out what you're given. You're given volume and you're given pressure. So, going back to what the ideal gas law is, you go PV equals nRT. Alright, they're going to give you this formula. Find all the things that are constant. What is not given in this they're not giving you the number of moles and they're not giving you temperature. So based off of that, you can just assume that those are constants. You don't have to worry about those anymore. R is just a constant as well. So the relationship is just PV. If you look at PV, it's just going to be PV equals to PV. Now what law was this from? Do you guys remember which law? Because on the final exam, they actually do have names. This is the ideal gas law. But this specific formula where it's P1 V1 equals P2 No. I think someone said it at the way beginning, but then like another question.
Well, we didn't have to memorize. You told us not to know them.
Well, for his exams, he said not to. This is just like a really small review. Okay?
Boyle's law?
Yes, it is Boyle's law.
Ideal.
What are the other laws?
Oh yes, what are the other ones? Yeah, there's Gay-Lussac, there's
Charles.
and there's Avogadro's actually. Avogadro's moles is crazy. I actually will write them down before the ones. So, write them down.
That's the hack.
So you got Boyle's law. Yes, you got. I think it's you call Avogadro's law. I mean, it has moles in them, so why not? Okay. So, really big tip. I don't know exactly if you're going to be given these specific laws and like in these forms, but the easiest way to remember it is basically just to use the ideal gas law. Figure out what is constant, and then just divide everything onto one side, basically. So if you only had pressure and volume, you're only going to use pressure and volume. It stays like that, so you're going to have PV equals PV. If volume is constant, the number of moles is constant, and the only things that are changing is pressure and temperature. Take temperature, bring it over here, P over T, you're going to get Gay-Lussac's law. It's basically P over T. Does that make sense? Just figure out what you have constant, bring it over, then you can get your formulas.
Can you write like in the numbers, like V1?
Oh, yeah, I can do that.
I would like this one in person.
Alright. So to answer this question, though, did we ever not answer the question?
Excuse me.
What did you guys get? 12 liters. Awesome. Does everybody understand how they got 12 liters? Basically, just 6 atmospheres times 4 liters divided by 2 atmospheres. And you get 12 liters. Good. This problem should not have taken like 5 minutes, but it took like 30 seconds, maybe less. Okay, so before I go even further, because basically this is basically just skimming the top of gas laws, they're going to give you some type of conceptual question about if I increase pressure, what happens to volume, you know? And what happens if I increase temperature, what's going to happen to the volume? If I increase pressure, what's going to happen to the temperature? If I increase volume, what's going to happen to the number of moles? But this was actually the exception, because the moles, you can't just like randomly get more. Right? So just make sure you guys understand that. So let me do it in a different color. So if pressure were to increase, what would happen to volume? Increase. Good. If volume were to increase, what would happen to temperature?
Increase.
Pressure, increase, what happens to temperature?
Increase.
Good. And then obviously this is the exception. You guys understand this is like basically kind of like the exception. All right. So, and it's also vice versa. Pressure decreases, volume increases. Cool. So if you guys are dealing with some type of gas problem and you guys don't really understand what's going on in the example itself, because it's a little too complicated, break it down to the ideal gas law and then work your way up from there. That'll help you out better than just trying to attack it head on. Okay? Is there any other topics besides gas laws? If you guys want me to go even further into gas laws, I totally can, but there's obviously a lot of topics to cover. So is there anything else that you guys are struggling on?
Thermochemistry.
Thermochem. What specifically about thermochem? Because thermochem is actually a class here, so there's a lot of stuff about thermochem.
Bomb calorimetry.
Let me just look at the topics.
Because in class we went over coffee cups and after this bomb calorimetry.
Was that on the?
I don't
We
know.
have a quiz of that.
Oh, do you guys actually have it?
Probably.
Are we supposed to get negative numbers? Negative 84 is right. What's the
My quiz.
negative 829. Spirit, that's helpful.
About that, I don't think I can actually help you with take-home quizzes. The main reason why is because my job is basically I cannot be giving you guys answers, and I mean I really
I'm asking you to give me the answer. Let's just
I would like to help you guys out, but it's very, very difficult. Like, I don't know, because like I know my teaching style, and I'm basically gonna be like, hey, so you can't really do that, but you can do something else. That's like the only other option that will potentially lead you to the answer that actually might be this, but I don't know. You can check it, you know. So that's gonna be like I'm basically gonna be giving you guys the answer, and then Zion's gonna be like, oh, why is everybody like doing really well?
does he not want to?
I mean, it's really suspicious. A lot of professors have been here for a very, very long time. They know when they see a random spike in someone's grade of like quizzes and stuff. You know, everybody should do well on the take-home quiz. You guys can collaborate between one another. You guys totally can. It's just I don't know about collaborating with me, but yeah. All right. So, what do you want to know specifically about calorimetry?
Bomb.
Bomb. You guys want to understand how to make a bomb? All right. Let me.
Oh, I'll just read one. Go ahead. Say. Do. Oh, I love my ball. Here's a 20. That's his.
Oh, sure. What? Oh, is that Cyan?
Yeah.
Okay. He does not belong here. What's he doing? If some of this doesn't make any sense, or like I might have like made like a really bad grammar mistake, please let me know. Numbers that look clear. Alright.
text.
Yeah. Just so you guys know, this is on the exam. They're gonna give you some like really big words, things that you might not have actually seen before. They're gonna try to trip you up that way. This is actually an example of one where they're gonna use like that random word, and you're gonna be like, "Whoa, what the heck is this?" But they basically give you all the information you need, so don't be scared when you think like that's like a really big vocab word or anything of those sorts. They just want to provide you additional information and see if you can actually dissect the problem and see what you really need versus what you don't need. So make sure you guys are paying attention to that. Okay.
Equations. Um,
Good.
No.
oh shoot, I don't remember
That's okay. That's
the
okay.
equations.
Correct me if I'm wrong on that. I'm not 100% sure. Trying to like poke some hints into it.
What's the second equation used for molar heat of solution?
Sorry?
That's the second equation used for the molar heat of combustion. That you wrote on the board.
Trying to figure out what you guys are going to do. Well, actually, if you guys look at it, this right here, this right here is equivalent to this. So the equation that you're going to be using in this specific problem is going to be this guy, because big C is what you guys can know.
Is what we want to know?
No, you know what big C is.
I thought that's what we're trying to solve.
It's not. I'm just trying to give this as like help you guys like start the problem. It's not like this is how you do it. It's more of like, hopefully it's gonna like trigger some memory back into calorimetry, you know? Like I said, it can't just like, I'll do that like once a decent amount of people is driving. You're fine. Alright, I'm just gonna go straight into it. Alright. So this one's actually a pretty tricky problem. I don't know if you're actually gonna see this on the exam, but it is good to know because if you guys work on stuff that are harder, make everything on the exam easier. Okay. So just won't look at this one. On this one. Basically, the first step of doing this is you want to find the Q. What is Q again? Can someone tell me what Q is?
Q is your,
Yeah, exactly. So you want to, in order to solve this, you want to be able to figure out what the heat of the material is. That's why I wrote that initially, because that's essentially what you need. A way to dissect this problem, actually, before you actually even approach it, is you go to the question. What do you guys want? You guys want to find the molar heat. Okay. So the molar heat of the combustion of that thing is basically going to be this guy, but they want the molar heat, so it's basically going to be divided by the number of moles. That's why they gave you the amount that you guys initially have. But in order to figure that out, you need to figure out what Q is, right? So that's why you have to first start how to figure out what Q of the material is. Okay? And Q of the material, which is, like I said, I gave you guys this equation right here. You guys are given this information in the beginning. It's going to be tricky. You guys need to really recognize that this value right here is not just that value. It's the fact that it says by 1 degree Celsius for every amount of joules, right? So that itself, C would equal 1560 joules per degree Celsius. Okay? That's what that information tells you just from the problem itself. Now, by implementing that in to there, you're going to get that 1560, and then if you guys want to write the units, it'll probably help you guys out a lot. If you guys do that, it's basically the difference in the temperature that it experiences when it's burnt. So it's going to be final minus initial, right? So it's going to be, what is it, 23.2. Is it 2 or 5? It's 22.5 to 20.3 degrees Celsius. Okay.
Why don't you not use the 10 degrees Celsius? What is a 10 degrees Celsius in the beginning?
It's 1.0.
I wrote, okay, never mind.
Okay. Okay. Yeah. So the beginning part is basically trying to trick you up by saying, instead of like saying that it's 1560 joules per degree Celsius, they split it up. Okay, so you guys just have to be aware of that. All right. Sometimes the values are not exactly what they mean until you read the whole entire sentence that encompasses that value. Okay. So just keep that in mind. So moving on. From here, you get this value, and so did anybody actually do this? Yes? Kind of, yes? Yeah. So what did you get a value? What was your value?
For Q?
Yes.
4,992.
Exactly. So 92 joules. Yeah. Just to make things a little simpler, because it's such a large number, I kind of like to convert these into kilojoules. So I basically would just round this essentially to what 5.0 kilojoules. Okay. You guys don't have to round. You guys usually the answers are not going to be that specific unless the question is actually about sig figs. Okay. Be happy that Zion was a stickler on sig figs because on the exam there's actually a few problems that are just like how many sig figs is this worth? How many sig figs is this? It's like straight up like sig figs. It's not like like I'll change like a few values and see if you actually understand what sig fig is. So yeah, just keep that in mind. Yes. Okay. Now we move on to basically with the next equation that I just gave you guys. Delta H equals to negative Q. Negative Q is equal to negative 5.0 kilojoules. Right. All right, now here we go into stoichiometry. We were given the value initially that we started off with, what? This right here, right? So we go in and we get 1.1964 grams. I highly suggest doing it this way because it makes a lot more sense. And you can cross out stuff, which is fine. So 108.1 grams per 1 mole. Bam, bam. You get a value. Anybody figure this out? How many moles?
1.817 times 10.8.
Yes. So it is 1.8. What? 3? 7?
1.7.
Oh, this thing is weird. Can you type it in again? Actually, like, is that what it's supposed to be? Because this thing is giving me something really different. Well, not really different, but slightly.
1.8.
1.82.
I got the same value. She just rounded off. It's 0.001816.
Yeah.
Stands for negative 3.
No, yeah. So it's 1.82 times to the negative third, right?
Yeah.
And that's how many moles. So, like I said right there, delta H over N is the value of the molar heat, because heat is delta H in this case, and is moles, so molar heat. That is going to equal, you should get negative 2.7 times 10 to the negative, wow, that's a really weird 10. Oh, that's not to the negative, that's to the third. My bad. It's 10 to the third, and then remember, you guys still need your unit. And then O, Q, U, I, N, I, N, E.
Ask a question.
Yes.
I can understand this equation, the H, the
Here?
letter H, yeah.
Here.
Oh, no, same question.
Oh, same question. So this is basically talking about, you know how you saw like the surrounding and then like the system?
Yeah.
It's kind of like that. Because the Q that we solved for, we were using the surroundings C value, right? From right, where is it? Because this was from the problem, it says that a certain impedance encompasses that it gains, right? So, and the delta H, in this case, is talking about the material, because that's why it's the change in heat of the specific material. And you know how it's like, if one thing is like, if the heat's entering into a system, then it is losing from the outside system, and then vice versa, right? So that's why we do it this way. This Q is referring to the atmosphere, and then this Q, or this delta H is referring to what's happening in the system, which is what happened to the combustion of that. Does that make sense? That's why they're opposite. Cool. Any other questions? All right. Calorimetry is, I actually honestly don't think it's a huge topic that's going to be on the exam. Obviously, there's going to be a few on it. But yeah, is there any other ones that you guys want to, or any topics that you guys want to review?
Molecular orbitals, maybe?
Molecular orbitals. So something you guys just did recently. Oh snap. Molecular orbitals. What specifically about it?
How to write it?
How to write it.
How to do it.
Could you also define delocalized orbitals? I never understood that.
Yeah, to be honest, I also didn't really pay attention to that either.
Well, he said it the last 2 minutes, and he said he's going over it tomorrow.
Oh, he did?
So, I don't know if I'll understand it after that, but anyway. He is doing that.
Let me check this out.
Yeah.
I doubt it'll be on.
Huh?
I don't think like the stuff we just learned will be on the test, because I asked him, I was like, I looked at the practice problem, there's nothing on like drawing or anything, I just like really too complicated.
There was not. And to be honest,
I mean, max, they're gonna give you like one question.
It'll be
It's
like,
not
what is like,
Yeah.
we give you like a little structure, like what hybridization, like ST2, ST3, but
Yeah.
I think that's
that's like.
Oh, do you guys understand that with the whole hybridization? Wow, I can't talk.
Yeah, hybridization.
Hybridization.
Yeah.
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 Yes, or did your teacher? Because you're the only one not from Zion here.
I'm sure like we're talking about like fundamental.
Oh, okay.
I don't know where is it.
Has he gone over organic chemistry with you guys?
A tiny bit, but not really.
Yeah. Like,
Okay. There were a few problems that were organic on the exam, so I'll probably just go over with you guys really quickly.
like equations and stuff, or just.
No, it's actually really easy.
Oh, like terms?
Kind of. They're gonna be like, name this molecule.
Really? Like that?
It's really easy. Yeah.
Oh, well, that we did kind of go over.
You guys, I know you guys went over it. I just want to like refresh your minds on it. So basically, organic chemistry it encompasses carbon. Okay, carbon is always the central atom, right? If I only have 1 carbon, 2 carbon, 3 carbon, 4 carbon. So what I mean by this is like, if I only use carbon and hydrogen, this guy right here is just. Actually, no, that's actually really weird. Actually, no, that's right. This is going to look like this. Okay. I'm not going to write the hydrogens, just wherever it ends, wherever there's nothing there, the hydrogen's attached to it. Just so it's easier and faster writing this. C here is the same thing. 1, 2, 3, 4, 5, 6. Right? Same here, so on and so forth. You guys understand the pattern? Okay, good. So basically just trying to figure out what is that compound? Like, what is that compound's name? Do you guys remember any of the rules? You guys do? Exactly, yeah.
Smoke is 4C, right?
So this is meth is for 1, F is 2, and then what was 3? Pro.
And then bute.
Exactly, and then bute, and then it goes pent, and then so on and so forth. And then, yeah, it goes like hex, set, yeah, basically all of those. Basically from that, then you guys have to figure out what the suffix is. Do you guys remember the rules for the suffixes?
Yeah, so single bond is in, double bond is in, and then
Exactly.
The triple bond is, yeah.
Exactly. So for those of you guys that did not hear that really quickly, A and E, there's E and E, and there's Y and E. So this is for single bonds. Oops. This is for double. And this is for triple. Yeah. All right. One way to remember this, instead of having to like try to break it down, I literally think of ain, een, and ein, and then you could think like, oh, I don't know like what the order is. I basically just go A, E, Y, alphabetical order, single, double, triple. That's the easiest way to do it. All right. Just pretty simple, just like that. All right. So basically, depending upon which one you use, it's going to change what the molecular like form of it's going to look like. So if I did like methene, it's going to look like C with the double bond and fulfilling the octet rule. It's going to, oh wait, that's not right. That's not right. Say that this was, what can I make it? I can make it an O actually. Yeah. Yeah. So it's going to be like something like that. All right. So that's going to have like an E at the end of it. Okay. So that's just like a super basic overview of what organic chemistry is. You're only going to see a few problems that are like this. I don't think you guys are going to have a lot on it. Yeah. Okay, super random. Do you guys understand what sigma and pi bonds are?
Yes.
Everything that has at least one bond, what is that called?
That's a sigma bond.
Yes, and everything else that's around it is going to be
A sigma and a pi bond.
exactly. Okay. I think there's actually one of the questions that asks like they show like a massive organic molecule with just carbon, oxygen, hydrogen, nitrogen, maybe. And they ask you how many pi bonds are there, and how many sigma bonds are there. All right. Yeah, I think it's probably in Zeppelin as well. That's most like I remember that being on the exam. So just pay attention to
I have a
that.
question.
Yeah.
Like, so sigma between orbitals that are not hybridized, or sigma hybridized and pi is not?
Mm.
Okay.
That's not. Wait. Is it?
It's the other way.
Is it the other?
I think sigma is not.
Sigma shouldn't be.
No,
Sigma's not, pi is, right?
Yeah, it should be the pi for the p
Yes.
orbitals then.
Mm-hmm.
Okay.
Just think of it this way: hybridized is a super funky thing, and single bonds are just really simple. So if you add more pi, it looks really, really funky. So pi bonds are hybridized.
What's the definition?
That's a very, very bad way of saying it, but it was just the point of difference. Okay. Anything else you guys want to go over?
It's like,
Can you give us like a definition of what hybridized means? Like what does it mean?
If you want a formal one, it is the idea that atomic orbitals fuse to form newly hybridized orbitals, which in turn influences molecular geometry and bonding properties. Hybridization is also an expansion of the valence bond theory.
so is it covalent? It's like, it's only for covalent, right?
Yeah.
Okay.
Yeah.
That makes sense.
Yeah.
Because they're sharing, so they have to overlap.
Exactly. Yes.
Why do we get the bond order? Why do we calculate the bond order?
The bond order. Sorry, I need to refresh my memory. Bond order.
So I know like if the bond order is 0 or below that, it does not exist.
I think it just So the bond order tells is the number of chemical bonds between a pair of atoms. So that basically just tells you how stable the atom is, or the
So if you got
compound.
like a half, what does that mean? Like half a bond?
You can get a half.
Yes. Like not 0.
Yeah.
Yeah, you definitely can have 0.
What about that one?
So if you have a
Oh, and also so
resonance,
it relates to the
5, 6, 9.
every time
it relates to the it relates to what I just said and the length of the bond, depending upon like how electromagnetic they are, or their electronegativity, like their affinity for each other. That'll depend on like the length, the bond between
Atoms
atoms.
sharing.
That's another reason why we do bond orders.
Any covalent.
But if it's a double bond, is it worth 2?
and then what's like the
So essentially, if it's like 0, 1, 2, 3, it tells you what the bond is between the two.
So that one's
It's
2.
either 1, 2. I mean, yeah, 0. I mean, it can be 0. It just means that there's no bond. But 1, 2, and 3 is single bond, double bond.
So that's 4,
And then if you want to get into halves and stuff, they get into like I believe they actually get into decimals
Every single one.
potentially, and it just shows like it is a single bond, but it's like either shorter or is it longer and stuff like that.
Because that's a pi bond, right? So
Don't worry about that. It's probably not going to be on. It's definitely not. I highly doubt that's going to be on the exam.
and what's a pi bond?
Pi bond is double and triple.
it is
If it's
And
double,
the structure sometimes can get like very confusing.
Oh yeah.
So
Yeah.
when I have a lone pair, when do I
Yeah.
connect with like a double bond instead of having lone pairs?
Yeah. No, I understand. I'll look up a few problems for you. That's really good.
So there's just one
Really,
here,
really good.
Yes.
One pair electron.
Okay, so she just asked about like Lewis structures, right? Yes. not gonna lie, with Lewis structures, it actually comes with a lot of practice of just constantly doing it because you eventually find a pattern as to how you're supposed to do it, rather than doing it how Zion does it, where you count the number of valence electrons, then drawing it all out, then subtracting this amount of electrons, the one that you use, what's left over, like all that stuff. It kind of gets tedious to do all that stuff, and actually kills a lot of time. So I'm gonna try to go through like a few tricks on how to do this stuff, but it's gonna be something that you're gonna have to just remember.
So that actually shows up on the exam.
What's up?
That's on the exam, right?
Okay, to be honest, I don't know exactly what's going to be on the exam. Main reason why is because they recycle exams throughout the years, so I'm just basing it off of what my experience was. I took it last year, so it's going to be relatively the same. They aren't going to significantly change it. It depends upon like how the nation does. If they do really well, they're going to try to increase it to be a little bit harder, and then like it's just going to depend on that. So I'm just trying to give you guys just like a general and like give you tips as to what my experience was. So, I'm only going to do these four really quick. Some of you guys just literally just straight up draw all four of these structures.
B is the exception, right? B and form, right?
And actually, I want you guys to give me the molecular geometry afterwards too.
Oh, okay.
After you guys draw, give me the molecular geometry. You guys really
Well, it's
That's on
Is it 4?
Sorry?
the atomic number of the tritium.
4, right?
For beryllium? I believe it's.
It's hydrogen being
I believe it's 4.
4, yeah. Oxygen.
boron 5.
Hopefully you guys have a periodic table. If you guys don't, sorry.
If you don't, I would be surprised if they didn't give
Yeah, it's 4.
Yeah,
because it is
Atomic number.
Oh,
how about boron? Boron is 5.
Boron's 5.
And carbon is 6.
Mm-hmm. Or, yeah, carbon is this. Yeah.
Carbon has 6.
Oh no, carbon is the 6th element.
Oh,
And it's 4th in its row, which will definitely help you guys out. Definitely help you guys out. This should take you guys like 10 seconds for each one. Coming up with the actual molecular geometry might be a little different, but what? That'll be fun. I'm trying to give you guys like a realistic like what pace you guys should be at. See, she's already done.
Well, either way, on multiple choice, if this is on it, it's like, it shows you the pictures.
Yeah. Or they're probably going to show you pictures and you can decide which one.
Yeah. Either way.
Is the exam multiple choice?
Yes, it's all multiple choice. It's not an exam that you're in Zion, correct? Yeah. It's not. He's not going to give you guys an exam that he made. It's the final exam that everyone in Chemistry 1 takes, like all across the nation. It's made by ACS, the American Chemical Society. They create the test.
Would you say it's easier than his tests?
no.
No, don't lie.
If I were to draw a scale from being really, really hard to really easy, tell me where to stop where you guys think Zion's would be.
So,
Oh, wow.
Huh?
Lovely.
I would
Wow.
think a little bit harder.
Okay, so someone said here. Now if I keep going down, someone tell me stop.
I would think there.
Right here. Okay, so this is the range at which you guys are all saying, right? From hard to easy, right? Really bad graph. But I would actually say that the exam would be from here to here.
Lying.
You're not.
I'm not
Everyone
lying.
said they got like 50%.
Okay, that's because those people just didn't study. Those people just did not study.
So it's a test you should study for, but is it that hard?
It's a test you should definitely study for. Like, I don't know. It's
All
a,
tests study
A
for.
lot of people went to that finals going like, I don't want to study. I really don't want to study. like they just weren't expecting it to be how they were expecting it to be. So they kind of just like underestimated it and was just like, I don't need to study, and then therefore they just weren't kept up.
Did you like do the practice?
If you guys have a practice booklet,
Will that help? Or
it does help.
should we like review sampling and our notes?
No, I actually highly suggest using the the booklet that
Is that
ACS provides. They actually have like multiple practice exams that you can take.
there's a copy online, guys, so go buy it.
There's like
Yes.
8 copies.
There's a lot of copies. Look
Or
it up
if you-
online.
Or if you don't want to buy it, go to the library and copy up all the
No,
pages.
there's an online
There's an
copy
online
on PDF. You
Alright.
just Google it.
So basically, definitely
what's
work
the
on
name of
that.
it?
That's what I worked on, and that's what
Google
gave
it,
me
yeah.
like a higher high B on the exam.
Well,
So
if you want the
ACS.
yeah, I believe it's ACS. I believe it's actually on your syllabus. They probably have that like a recommended thing that you guys can get from that. So, time has just been wasted. Lewis structure.
Yeah.
BF2. Someone tell me what's up. Or if you'd like to come up and actually draw yourself, that'd be awesome too. But that's probably gonna waste time. So,
Just sort of like Lewis structure would be like a straight line,
okay.
where it's F, B, F.
So what's in the middle?
In the middle is your BE,
Cool.
and then you have F fluoride on either side, and then you have it'd be single bonds,
Okay.
and each fluoride would have 6 electron pairs.
Oh my god. Okay. I'm not gonna draw them. You guys understand because this
It
is smart.
has 6 electron pairs, and then BE has 2.
Yeah. So there's 2, 2, 2, and then 2, 2, 2. Okay. That's like the formal of what it should. That's the Lewis dot structure. That's what it should look like. Okay. Make sure they're gonna trick you guys up by not putting the right amount of electrons, like the valence electrons around it. So pay attention to that small detail. All right. So what is the molecular geometry of this?
Linear.
Exactly. This is linear.
So beryllium does have two electrons.
Yes. 2 valence electrons. Okay. Does that make sense to everyone why it's linear? Should be pretty. So that one should be pretty easy. Next one. Who's got the next one?
Straight.
Anybody got the next one?
I can guess.
Go for it.
Alright, you do B, and then you do CL on whichever line.
They obviously want to be furthest away, and then what?
Oh, we have to add more than one. Alright, single bonds.
Oh. No wonder it was
I was
so
like, wait a
easy.
minute. Wait, you have to put multiple ones. What are you
No
saying?
wonder it was so easy.
Okay, anyways, yeah.
Alright, and then each one gets 7 dots for this.
Yeah. Well, no.
Yeah.
What?
2, 4, 6.
6, yes. 1, 2, 3, 4, 5, 6. And then that's repeated on the other ones.
Alright, and it's trigonoplanar.
Yes, it is trigonal planar. Does everybody understand why it is trigonal planar?
Yes.
Okay, cool.
Three things surrounded in the central atom with no lone pairs.
Kind of, yeah. So you can either think of it methodically, like what Steve's doing, like going through the specific steps. But I'm more of a visual learner. Are you a visual learner? Okay, good. So I'm just imagining this in a 3D space, trying to extend. What?
Do you have to have the whole chart memorized? Like AX2?
You don't need to. This is what I'm trying to explain in a more visual way. That'll help you guys out in the long run. Because how they named everything, it's really like methodical and like the first one, it's a line. You think of line, you think of linear. So that's why it's linear. You know. So I'm going to explain why this one is trigonoplanar. So if you look at it in a 3D space, it's basically they just want to be as far away from one another, and the only way that's possible. That's why he did the whole, hey, can I have volunteers come down and let me embarrass you by directions. So basically, he had the central atom here, and then he spread out 3 people as far away as they could. Just keep in mind, every time you see this type of shape, or anything that has a 1 to 3, basically, it's going to be spread out into a triangle. Okay, and that triangle should immediately trigger your mind to think of trigonal. Okay, and the fact that it's only on a plane, like it's only on one level, that's why it's planar. So a trigonal. Does that make sense?
So what about pyramidal?
Right?
Trigonal, pyramidal.
Trigonal. Five. In 3D space, that would look like trigonal. It's gonna look like. Can you see that? Three-dimensionally? Like, let me actually do it a little better. This guy's going in the board. This guy's coming out of the board. And then this is going on an axis, and then this is the z-axis. Does that make sense? Oh, that one you just draw it on like a 2D plane. So you don't. It's if you actually just want to do that. I'm just gonna use x and y as just variables. Like just say y is the central atom. You basically just draw it how you just would. Like 1, 2, 3, 4. Because you have like y. It's gonna be 1, 2, 3, 4, 5. So you just basically just draw it as like a star. Just be like central 1, 2, 3, 4, 5. There's no other way to really draw it unless you want to draw it like this, but you don't really have to. All right, next one. CCl4. You can tell me. This one should be that.
Your central atom is around it, and
There you
then
go. Cool.
Cl is around it, and then single bonds,
Cool.
3 bond pairs around it.
You mean 3?
Bond pairs.
Oh, yeah. Okay. Sorry, I didn't hear you say pairs. Yeah, that's right. Awesome. So what is the molecular geometry of that? Yes, tetrahedral. Does that make sense?
It's
Okay. One thing to notice that the one thing to know is that they might trick you up by having some type of element on the central atom having like some type of random lone pair on it, which is going to completely change the geometry of it. And you guys understand how that breaks down? So I highly suggest just like looking at those. It's not going to get too complicated where it's going to go into like super ridiculous manipulated octahedrals. It's not going to go that deep. That's a little too crazy. But actually, this example is actually an example of the trigonal bipyramidal. Actually, yeah, that's the next one actually. So anybody figure out what the next one is? Or what it looks like?
P in the center.
Yep.
5 VRs.
Yeah. So it's just like 1, 2, 3, yeah. So VR. Cool. So this is how you basically would draw it. If you want to draw it like three-dimensionally, you can, but it's all multiple choice. So you don't have to worry about drawing anything. And this would be called trigonal bipyramidal. How you would figure that out? I think of right here is going to form a triangle. And then when you connect these going up and this guy going down, it creates a pyramid, and there's 2 of them. So trigonal bi, 2, pyramidal, 2 pyramids. Right? Cool. And then if you have something that's 1 to 6, what is that? Anybody know? 1 to 6.
What do you mean?
1 being the central atom, and then like 6 of whatever. So essentially, yeah, exactly. Octahedral. Okay. Cool. And then there's also like some weird, funky ones. This one actually might. I don't know if they might do this one, but what is H2O? Do you guys remember what H2O is? Yes. It's bent. Okay. That one is like kind of like a universal thing to just remember. Water's really funky, so water's bad. All right. Enough of that. Hopefully that helped you out. Good. Okay.
Excuse me. I burped.
Oh, okay. Oh shoot! Wow, time just flew.
Yeah.
Any other last? Yes.
Resonance structures?
Resonance structures. Okay. Resonance structures are not that difficult as they may seem. A lot of it has to do with organic chemistry. You're probably going to see it in a lot of organic chemistry. Let me try to think of. I'm not going to go that deep for you guys. Okay, so basically, like you know how we're talking, like say if you have 5 carbons, there are multiple ways of drawing it, or like a structure with 5 carbons. So you draw it as like one massive chain, correct? But you can also draw this like this. That still has 5 carbons, right? That would be considered like a residence structure.
I thought residence was like, has like the same shape, but like the.
But it can flip.
Yeah, and
Residence
it can flip.
means that there could be
Oh,
more.
okay. I'm thinking of something completely different.
You
My bad.
isolate-
Of isomers. Wow, my bad. I'm so sorry.
Isomers is the same. It's the same.
Yeah. Yes. That's very true. Okay. Here we go. Scratch that. Don't even think about it. Actually, I didn't even need to do that. It's definitely right. All right. Residence structure. Let me do something. NCS. That's right. Not exactly. So it's going to be, okay, you guys are going to see this note. Are you taking chemistry too?
Yes.
You will? Okay. I'm going to do this up. What is your major? You're definitely going to see this. All right, so see, Novan S. Holy Jesus. Okay. So when you were given a compound, something like that, there are a lot of variations, specifically in a lot of organic chemistry. There's going to be a lot of resonance. Basically, what resonance defines, what it is defined as, is you need to draw all of the variations, bracket all together, and that is your answer. If you only have one of them, that's not the whole answer, because the molecule can, it has like intermediate stages, and you're able to essentially change. It's weird, but it'll be able to change within the make. Does that make sense? So what that means is you're basically going to draw that, and then you're going to draw, or write, N 1, 2, 3, C 1, 2, 3, 4, and then H 3, C, and 1, 2, 3, 4, here C 1, 2, 3, S. Okay, so you have to actually draw all three of these. You actually need to draw all three of these in order to actually get the answer correct. Okay. I don't know if you're actually going to see this on the exam, because it's going to take up a lot of space if you have these. The importance of resonance. I mean, if anything, I could see it being as a multiple choice, like just word problem, as in like, what is resonance and what does it tell you, stuff like that. So I kind of just explained it. You need all the resonance structures in order for it to actually be equivalent to what the compound is actually. Cool. Any last minute questions? Terms. Like, what do you mean by terms? Give me an example of this term that you're thinking of.
Isotope isomers.
Yes, you're going to need all those. Obviously, this is like the standard like ions. What are anions? Like you need to know those.
What are cations?
Yeah, exactly. You need to know that stuff. So those are going to be more based upon like just simple, just straight questions rather than like working problems out. So yeah, just try to go over those really briefly.
It sounds like it's going to be a relatively easy test.
Yeah.
Chemistry is math.
Yeah. Most likely. This is definitely going to be
Well, I wish you all luck.
That's going to be like one. They do. Massive formulas, credit table, and then the next page.
Once it's over, it's over. There's nothing you can do
Kind
about
of
it.
annoying, but those books are like. I mean, I guess you could.
So that's like, oh, you didn't ask about this.
Yeah.
I have some jam times specific examples from like
That's fine.
practice.
Yeah, sure.
You don't know what quiz
Oh, different numbers.
Oh dear.
Oh,
You should know next week your notes.
You're in the same class.
no, like for some reason,
Oh, got it.
it's weird. It's all the same blackboard, but it's like just different numbers.
This is the one that he emailed.
This is the one that he emailed me.
Yeah.
I got